The James Webb Space Telescope has ripped open a new chapter in cosmic history with the jaw-dropping discovery of colossal red monster galaxies flourishing when the universe was a mere infant. Observations that fundamentally clash with our understanding of how galaxies form and evolve. Peering back to an astonishingly early epoch, just 500 to 700 million years after the Big Bang, JWST's unparalleled infrared vision revealed these behemoths. Their defining characteristic, a pervasive red hue, isn't just for show. It's a direct signal from ancient, cool stars, indicating these galaxies were already dominated by vast populations of old stars at a time when the cosmos was thought to be filled only with youthful, blue star-forming systems. This red and dead state implies their furious star-forming days had already peaked and ceased incredibly early. Renowned physicist Brian Cox remarked that the red monster galaxies observed by the James Webb Space Telescope are truly mind-blowing. The discovery of massive metal-rich galaxies that were already dead, their star formation quenched, when the universe was just 700 million years old, suggests a phase of star birth and death of extraordinary efficiency and speed, far exceeding current models. Cox added that this implies the first stars ignited astonishingly early, possibly within the first 100 million years, governed by physics we do not yet fully understand. This isn't just a surprise, he said. It's a fundamental challenge to our understanding of galaxy formation, pointing to a far more explosive and accelerated cosmic dawn than we ever imagined. The sheer scale of these monsters is staggering. Spectroscopic analysis confirms stellar masses ranging from 10 to over 100 billion times the mass of our Sun. Galaxies like ZFUDS 7329, observed just 700 million years post-Big Bang, boast a mass of roughly 1.6 billion solar masses, rivaling or even exceeding the stellar bulk of our mature Milky Way, a galaxy that took over 13 billion years to accumulate its stars. Finding such titanic structures so early is unprecedented and demands an implausibly rapid formation history. To amass this much stellar mass so quickly, these galaxies must have sustained mind-boggling star formation rates, hundreds, even thousands of solar masses per year, dwarfing the Milky Way's current rate of roughly 1 solar mass per year. Even more baffling, this frenzy didn't just slow down. JWST's spectrographs show it abruptly stopped, leaving them quenched while the universe was still in its relative infancy. Adding to the enigma, these galaxies are surprisingly compact, yet immensely dense, packing their enormous mass into relatively small volumes. Crucially, their spectra reveal another bombshell: significant metal content, elements heavier than hydrogen and helium. Metals are forged in stars and scattered by supernovae explosions. Their presence means not only was there a burst of incredibly rapid star formation, but a prior generation of stars had already lived full lives, died, and enriched the galactic gas before the observed red stars formed. This implies multiple, intense cycles of star birth and death occurred within the first few 100 million years, a timescale current models deem impossible. Galaxies like Sears 1019 and ZFUDS 7329 stand as prime examples of these cosmic anomalies. Their existence throws the prevailing lambda CDM model of cosmology, underpinned by dark matter, into crisis. Simulations based on this model cannot produce such massive, quenched galaxies so early. The fundamental issue is time. The dark matter halos massive enough to gravitationally pull in the required matter to form such behemoths simply shouldn't have had enough time to collapse and grow to the necessary size. The red monsters suggest one or more radical possibilities. The very first stars ignited astonishingly soon after the Big Bang, perhaps within the first 100 million years. Star formation in these early giants was monstrously efficient, far exceeding theoretical limits. Or our understanding of dark matter halo assembly, star formation physics, or the feedback mechanisms like supernovae or active black holes that shut down star formation is fundamentally flawed or incomplete.